Have you ever wondered how your computer mouse knows exactly when and where you move it? It's a fascinating piece of technology that we use daily without giving much thought to its inner workings. Today, we're going to dive deep into the mechanics of computer mice and uncover the incredible engineering that makes them function. At its core, a modern computer mouse is a sophisticated device that combines multiple technologies to track movement and translate it into cursor motion on your screen. The most crucial component is the optical sensor system, which has revolutionized how mice work since their introduction in the late 1990s. Let's start with the basics. When you look at the bottom of an optical mouse, you'll notice a small lens and what appears to be a red or invisible light. This is actually the beginning of a complex system that involves precision optics, advanced image processing, and sophisticated mathematics. The process begins with an LED or laser that illuminates the surface beneath the mouse. Most modern mice use infrared LEDs, though some high-end gaming mice employ laser technology. This light doesn't just illuminate the surface, it creates a detailed pattern of shadows and highlights that the mouse uses to track movement. The illuminated surface is then captured by a tiny camera chip inside the mouse, typically capable of taking thousands of pictures per second. These aren't the kind of pictures you'd recognize. They're more like microscopic topographical maps of the surface texture. Even what appears to be a smooth surface to our eyes contains minute variations that the mouse can detect. This imaging system is incredibly precise. The sensor typically captures between 1,500 to 12,000 frames per second, depending on the mouse's quality and intended use. Gaming mice often feature higher frame rates for more precise tracking. Each image is processed by a dedicated chip that compares consecutive frames to determine how far and in which direction the mouse has moved. The resolution of these sensors is measured in DPI, dots per inch, which indicates how many pixels the cursor will move for each inch the mouse travels. Basic office mice might offer 800 to 1200 DPI, while gaming mice can reach astronomical numbers like 25,000 DPI or higher. However, these extremely high DPI numbers are often more about marketing than practical usage, as most users find such sensitive settings unusable. The magic happens in the digital signal processor DSP, which performs complex calculations to determine movement. When you move your mouse, the processor compares each new image with the previous one, looking for patterns in the surface texture that it can track from frame to frame. This process, known as optical flow detection, happens thousands of times per second. But how does the mouse maintain accuracy across different surfaces? The answer lies in the sophisticated image processing algorithms. The mouse doesn't need to see colors or detailed images. It's looking for contrast and patterns in the surface texture. This is why most mice work well on paper, cloth mouse pads, or wooden desks, but might struggle on glass or highly reflective surfaces. The mouse's sensor typically captures a small area, usually about 18 by 18 pixels, though high-end mice may use larger arrays. This might seem small, but remember that it's capturing this area thousands of times per second. The processor then uses these rapid-fire images to calculate velocity vectors, determining both the speed and direction of movement. Modern mice also incorporate acceleration detection, which helps maintain accuracy during quick movements. This is particularly important for gaming, where precise tracking during rapid movements can mean the difference between victory and defeat. The data from all these calculations is then transmitted to your computer, typically via USB or Bluetooth, at a rate known as the polling rate. Gaming mice often feature polling rates of 1000 Hz, meaning they update the cursor position 1000 times per second, while standard mice might use 125 Hz or 250 Hz. The evolution of mouse technology continues with new innovations. Some gaming mice now feature adjustable weight systems, programmable buttons, and even dedicated processors for handling complex macros. The latest sensors can track movement on virtually any surface and maintain accuracy at speeds exceeding 400 inches per second. But perhaps the most impressive aspect of modern mouse technology is its reliability. Despite the complexity of the systems involved, mice rarely fail and can maintain accuracy for years of regular use. This reliability comes from the lack of moving parts in optical mice, unlike their mechanical predecessors that used balls and rollers which could collect dust and debris. The future of mouse technology looks even more promising. Manufacturers are developing sensors with even higher precision, lower power consumption, and better performance across different surfaces. Some are even experimenting with new technologies like depth sensing and gesture recognition. Understanding how your mouse works might seem trivial, but it's a perfect example of how sophisticated engineering can create something that feels completely natural to use. Every time you move your cursor across the screen, you're utilizing a complex system of optics, electronics, and mathematics that has been refined over decades of development. Next time you use your mouse, take a moment to appreciate the incredible technology working beneath your hand. It's a testament to human ingenuity that we've created such a precise and reliable interface device that millions of people use every day without even thinking about it. What do you think about this fascinating technology? Have you ever experienced issues with your mouse on certain surfaces? Let me know in the comments below, and don't forget to like and subscribe for more interesting tech explanations like this one.